Good morning. Today I will start the topic pumps, compressors and prime movers. This is very vast topic actually. So I will try to compress to put into 1 week lecture. Uh, first I will start with pump. What is pump? Pump actually when you are delivering fluid from one point to another point, and again you are adding energy to the fluid. How you are adding energy? They say your fluid is here and you want to lift here. They say you have Burj Khalifa, okay, and you want to lift fluid from ground floor here to here because there will be lots of residential building and business units. So you have to deliver fluid. So how will you deliver? You have to add energy to the fluid so that fluid static head will be increasing, okay. Or you have hostel or you have in residential houses, there will be overhead tank. So overhead tank you want to fill with water, you need to add certain amount of energy. So which energy will be coming through pump, and from where it is coming? Maybe it will be coming from prime mover or electrical motor, okay. So pump, normally there will be two types: centrifugal pump, reciprocating pump. And if I say compressor, compressor also it is similar like pump, okay. It will have reciprocating and centrifugal type compressors. Now many times you have heard the term turbine, many times you have heard the term pump, fan, blower. So what are these things actually? So if I see adding fluid, adding energy to fluid is done by pump, okay. But when you are taking energy from fluid, so this is turbine, taking energy from fluid, is called turbine, okay. So using this definition, actually you can see this adding energy to the fluid. So ceiling fan at home at summer time, you normally use ceiling fan, low speed fan on your head. It is rotating, is actual type ceiling fan. This is actually pump. Pumping means you are delivering energy to the fluid. Again blower also will be doing same thing, you are adding energy to the fluid. But if you see turbine is gas turbine, steam turbine, wind turbine you have seen maybe. So these are extracting energy from fluid. So just opposite of pump is turbine actually, okay. So you should not get confused. But if you see propeller of, let's say, marine propellers or aircraft propeller actually you are adding energy to the fluid. So actually it will be coming under pump category, okay. But aircraft engine, there will be gas turbine, so there will be turbine systems, okay. So first you differentiate the pump and turbine. Turbine means you are taking energy from fluid, but in your fluid surface production operation cases, normally you are giving energy to the fluid, you are not taking energy from fluid, okay. When you are transferring fluid from wellhead to choke to separator 1, separator 2, or maybe you are compressing gas. So every time you are adding energy to the fluid, liquid, water, liquid oil or gas. Normally you are not extracting energy from that fluid. If you are burning and changing chemical, doing some work, or you are giving some chemical reaction, that story is different. But physical transformation happening, like phase change occurring or compressing, decompressing, in that case you are using the term pump and you are using for surface production operations, okay. And every time I give one example, this oldest pump and which works more than 80 years, 90 years, 120 years. If you read the book of Ikigai, the good life, how to lead a good life and happy life, Ikigai. So the people in Japan, they will be living more than 120 years also, okay. Their heart running 120 years. So this is oldest pump and it is running more than 120 years, right. So this is the oldest God made, the pump. So delivering blood, if it is stopping for a moment, 1 minute, 2 minutes, you are gone, okay. So this is the oldest type of pump. It is reciprocating pump actually. It is continuously giving, like, compression, decompression it is doing, and it is increasing pressure to the fluid, and fluid is getting delivered to your brain, to your toe, to your finger, everywhere, right. And it is so that's why you are surviving, okay. This one reciprocating type positive displacement pump, okay. It is there is no centrifugal pump in heart. this is only reciprocating type. Later I will discuss about reciprocating and centrifugal difference. Here one picture I have taken from one Bollywood or Indian movie, this Pipli Live. So this is actually a reciprocating pump. In Indian household or Indian rural areas, if you see this hand pump is used normally. So this is called reciprocating type pump. Reciprocating type pump. Okay, type pump. Okay, reciprocating type pump, and it is manually you are operating, so speed will be very low and flow rate also very low. Okay, but it's good for household applications or normal rural applications. Even in many cases agriculture applications also will be there. But many cases there will be centrifugal pump where you need higher flow rate. Higher flow rate you need, so you are using centrifugal pump. For lower flow rate you are using this one. So this is lower flow rate. Okay, so reciprocating type pump used for household applications. This is lower flow rate applications, but it can develop very high amount of pressure or high amount of very high, if the pump can lift a very high tall building or very high head, we say. Head means like how much pressure it is developing. If you convert into water column height, so that will be called head. So water column height like H rho G. Okay, that much pressure you are developing. Okay, so if you know the pressure, then you can calculate H. So H equals P by rho G. Okay, you can convert how much water column height you can develop. So that is called head. Okay, so reciprocating pumps can develop very high amount of head, but flow rate is very low. But in other words, centrifugal pump I will define later. So that will have very higher amount of flow rate, but head will be little bit lower. So there are applications where you can use centrifugal pump or reciprocating pump. I will explain later. Okay, and reciprocating and centrifugal pump, where to use? Normally centrifugal pump will have higher volume flow rate. So where you want to handle high amount of fluid, so in that case normally you use centrifugal pump. But you want to develop very high amount of pressure. For example, gas lift application, you are injecting very high pressure fluid, or let's say mud motor, you want to inject very high amount of that mud pump. So high amount of high pressure fluid, maybe lower amount, high pressure fluid you want to pump. So in that case normally you will be using reciprocating or positive displacement type pump. So these are called positive displacement also. Okay, positive displacement type pump. Okay, this is hand pump. You can see this one hand pump. It will okay, one rod is going, so the rod will have going there, and there will be one piston actually, piston with valve. Okay, so with piston will have valve arrangement also. So it will be designed such a way so that one way it will be delivering fluid. So when it is you are lifting the handle of the system, this is handle. Okay, so handle when you are lifting, it will not be delivering. When you are pushing down, it will be delivering. Okay, so one stroke only it is delivering. So it is pulsating flow. It is giving pulsating flow. So it is giving pulsating flow. Okay, pulsating means one time delivering, two time delivering, three time delivering. In heart also you have pulsating flow actually. So previous days, older days when there was no electronic the temperature sensor, so that time doctors will be checking the pulse here. Pulse here means heart is beating, so that heart beat will be giving fluid in pulse manner. Okay, so if you press it this area, this one, so doctor will be counting how many beats they are getting here. So based on that they will decide whether the patient is having any fever or not. Okay, this is called pulsating flow. Okay, this is not a smooth flow, but if you are using centrifugal pump or some other type pumps are there which will be giving continuous flow, there in that case you will not get any pulse. Okay, so pulsating flow is having their own positive negative aspect. So normally in oil industry you need continuous fixed amount of fluid to deliver. Okay, then if you have reciprocating pump, then how to make it continuous, that also I will discuss here. Okay, so I said like positive displacement, reciprocating, centrifugal. So let's see the difference. So basically pumps, okay, pumps actually adding energy, pumps actually adding energy to the fluid. Okay, so Now pump basically two types, one will be positive displacement type, another will be hydrokinetic or hydrodynamic. Okay, hydrokinetic also say, kinetic pump we say, kinetic pump. Okay, so positive displacement pump basically there will be two types, one will be rotary, reciprocating. Reciprocating time, what, like your heart, okay, right, it is reciprocating or pulsating thing, or you have any reciprocating pump you have seen in industry, I will discuss later. Another rotary type. Rotary type actually like PCP, if you understand the progressive cavity pump for your artificial lifting application in oil and gas industry, this is rotary type pump. So there are several other types also there, gear pump is there, vane pump is there, lobe pump is there, screw pump is there, and maybe many other different variations of pumps will be available. Reciprocating will be single cylinder, axial piston, multi-cylinder, simplex, duplex, many types will be there. So because our time is limited for this lecture, for this week 12, so I will not discuss everything, rather I will discuss only positive displacement reciprocating type, okay, single cylinder. And for hydrodynamic or hydrokinetic pump, I will be using the centrifugal thing. Okay, centrifugal basically radial blade, radial blade pump. So axial flow and mixed flow I will not discuss. Okay. So when I will discuss in detail, so that I will understand what is centrifugal, what is axial. Okay. So I will show some pump here. So I say rotary. Rotary means like progressive cavity pump I told. So progressive cavity pump will have like one rotor. If you can remember your artificial lifting system PCP, PCP will have one rotor, one stator. Stator means this is not rotating, rotor will be going inside this one and it will be rotating. If you see this stator, stator is having one hole. So this rotor will be going inside this one, okay. And inside there is elastomer coating here. This is metal solid and inside this one elastomer coating. So when rotor is rotating inside continuously, so fluid will be delivered from one point to another point, okay. So the whole rotor, this metallic rotor will go inside this one, okay. You see the inside a through hole is there, okay. This through hole, this rotor will go, and if you rotate it, it will create certain cavity and the cavity will be progressing slowly, okay. So it will be creating almost continuous flow, okay. But this is very low speed pump. Normally this is called, actually this is called screw pump or single screw. So this is single screw pump. Single screw pump means another name is the progressive cavity pump, okay. So it is having speed normally 300 rpm, okay. So PCP will have normally 300 rpm, and this is very good for very high viscosity applications. For example, you have very thick fluid connect, let's say toothpaste, grease, or that sort of very thick fluid where other pumps will be failing to deliver. You use PCP, it will be delivering without any problem, okay. But there will be certain limitations also, but very high, very thick fluid where viscosity very high, you can use this progressive cavity pump safely. Okay. So reciprocating pump I am not showing here, I will show some centrifugal pump, okay. You see the centrifugal hydrokinetic pump or centrifugal pump. Centrifugal pump will have one impeller, and impeller will be rotating inside one casing or volute casing, okay. So this is called volute casing. If you see any centrifugal pump, it will be drawn like this also, even in actually also it will be looking like this. And my impeller, this will be inside this one, okay. So impeller will be like this and impeller will be rotating. So okay, so impeller will have like 7-8 blades, let's say 6 to 8, about 6 to 8 blades for liquid applications, okay. About 6 to 8 blades. How many blades it is having? 1 2 3 1 2 3 4 5 blades are there, okay. So this is one, this is called impeller. If it is impeller rotating continuously inside one casing, so it will be delivering, or it will create very high volume flow rate, very high pressure or high velocity will create. That high velocity will be reduced using one diffuser, okay. So the diffuser, this area actually will act as a diffuser, So diffuser purpose is to reduce kinetic energy and to develop a static head, kinetic head or dynamic head. I can write dynamic head. And it will be developing static head. Okay. So what happens in impeller, when impeller is rotating at very high speed, it will be sucking fluid here through this channel and it will be delivering at very high velocity. Okay. So this is called impeller, impelling, or it is taking fluid from this area is called impeller eye. Okay. This area, this entry area will be called impeller eye. Okay. And these are impeller blades. Okay, I am drawing, you see this impeller blades. Okay, there will be 6 to 8 blades normally, but it will be 5. For example, my impeller is having 5 blades. So within that range, we cannot get like 100 to 100 blades. For 6 to 8 blades will be okay for normal application. This is 6-inch blade. Actually, we purchased from local shop and we cut this one for academic demonstration purpose so that the student can see. These are called blades. Okay, you see these are called blades. Okay, and this is called impeller eye. The fluid will be entering through this. This is my shaft. This is my shaft actually. Okay, my finger, you can see my finger is shaft. If I rotate shaft, my impeller will be rotating. Okay, when it is rotating at very high velocity, what will happen? This fluid particle will be leaving, because at very high velocity, if you rotate something, the fluid will be trying to go away. Like cycle mudguard you have, right? Cycle, when you, if you drive cycle at very high speed and if you don't have mudguard, all mud will be going on your head and all back, right? So because this splashing, okay, the particle will be trying to going away from the center to the furthest distance. Okay, and it is having some guide channel. You see the blades are there, solid metal. Okay, this will be acting as a guide channel. Okay, so if you rotate at very high speed, so fluid will be sucked here. This at impeller eye. This is impeller eye. It will be going through the channel. It will be exiting. When it is exiting, it will have very high velocity. So very high velocity, if you take directly to pipe and you deliver, actually there will be lots of losses. So what you do, when you get very high velocity fluid, you have to reduce the fluid velocity and you have to increase your pressure. If you remember the Bernoulli's formula, if you change the velocity, pressure will be changed. Okay, so you reduce pressure, so velocity will be, so it reduce velocity, so pressure will be increasing. So it will happen. So this will be inside one casing. So this is casing. You can see this volute casing or casing they say. Okay, this is casing actually. This outer circular section I am drawing. You see this. Okay, this is called casing. Okay, so casing will be collecting all the fluid whatever going out from this system. Okay, and all the fluid will be going out through this. Okay, so and fluid entering here. Okay, so where fluid entering at impeller eye, this hole is there, my finger and this area, you see some gap is there. Okay, so this gap area fluid will be entering, it will go through these channels, it will be going at very high velocity going out, and this is inside one casing. So casing will be collecting all the fluid and it will be delivering. Okay, when it is delivering, it will be reducing velocity, it will be developing pressure. How it will do? This special shape called diffuser. Diffuser shape will be like this. Okay, so when fluid is entering, you see this wider section is there. Exit portion I have drawn like this, wider. Okay, so narrow then wider. So narrow wider means it will reduce fluid velocity, increasing fluid head, static head or pressure. Okay, so diffuser purpose, it will reduce fluid dynamic head and increase static head. Okay, impeller eye purpose is to allow fluid to enter. Okay, and shaft purpose to give rotational torque. Okay, this is shaft. Shaft will be giving rotational torque. Fine. And these are called impeller blades. Okay, impeller blades. So actual, what is the actual impeller shape and size? You see this one. If you do the same thing, we cut, we redesigned again and using some softer material. So, this is a lighter weight. This is purely metal, so I cannot throw it. Okay. This is lighter metal. We have designed this one, and in our laboratory, in my laboratory actually, I tested this one. I did not test this one because I want to modify different shape, size, and I want to explain in class. So I thought let's cut it, and so that it will be good for a student to understand. So here you see this impeller eye. Okay, this one impeller eye, and this hole is there. This is shaft hole. Okay, and blades you cannot see here. So blades 1, 2, 3, 4, 5 blades will be there. 5 or 6 blades will be there. I think 5 blades are there. So now this blade will be like going like this. If you see, it is going out. Okay, it is going like this. Curve will be there. Going. All pen marking possible. Let me check. So no, not visible. So it is going like this, impellers. Okay, so it is fluid sucking. It is delivering directly. Again, one thing is that it is going in this direction, fluid, and fluid is taking turn 90 degree. Okay, it is taking turn 90 degree. You see this again, fluid entering here, shaft is there, so it cannot enter through this because solid metal is here. Okay, fluid going there, taking directly 90 degree turn. So this is called radial blade. Radial. Axial means fluid will be going, axial it will go. Like if you see ceiling fan on your head, like in summertime you use. So ceiling fan will have axial flow, or wind turbine you have seen axial flow. So turbine will be there, so actually air will be passing. It will not be taking turn 90 degree. Okay, but in this case fluid is taking turn 90 degree. Okay, so when you are taking turning to 90 degree, this head or pressure development will be very high. Okay, but if it is having purely axial, like wind turbine or ceiling fan, they cannot develop very high pressure. Ceiling fan actually pressure difference will be very low. It is just small amount of fluid delivering on your head, so that you can feel cold. Okay, so the purpose is to just create turbulence and give small amount of fluid blast actually. But here this purpose is to increase high pressure. So that's why you're giving 90 degree turn. Okay, so this is called impeller. Okay, the whole thing is called impeller. Okay, the term you should remember, this is called impeller, this is called blade, impeller eye. Okay, and this is shaft. Shaft will be there because I did not bring my shaft. I will show another impeller is there, so their shaft is there. Okay, so many types of pumps are there, but I cannot discuss in this class. Okay, so I'll be discussing only reciprocating and centrifugal. Centrifugal means basically this one, because I have done experiment, so I'll be showing experimental procedure and everything. Okay. Experimental setup. So this one was done in my laboratory actually at IIT Madras. So how I did experiment? You see, first you see the line diagram. I had one tank. Okay, tank is having one inlet suction pipe. My pump is here. Okay, so from pump, fluid was delivered and it went back to the same tank. Okay, this is continuously circulating same fluid. So why I am showing this one, because I used different fluid like drilling fluid. We use crude oil for pumping, and we want to check what is the performance of pump. Instead of water, if you are pumping crude oil, different viscosities or different slurries are there in bentonite if you mix, then what will be the performance. So a few PhD students has done some research and they got degree also. They did design optimization and playing with different viscosities. So okay, now suction pipe, this is called suction pipe. So from pump, I'll show this one. Well, I said this one impeller eye. So one casing is here. So from casing one pipe will go. Okay, so pipe will go to tank or water supply section. Okay, so from water supply fluid will enter, then it will be delivering. It will go out of this impeller, volute will be there, then diffuser will be there, diffuser will be delivering to delivery pipe. So where is my delivery pipe? This is my delivery pipe, you see this part. Okay, so this is outer part of impeller is delivery pipe, and if I link with this my actual experiment, what I have done in my laboratory, this is tank, okay, this is, you can see this one as it is, and this is a suction pipe, here is my suction pipe, okay, and this is the pump, this pump was there tested here, okay, and this is my delivery pipe, delivery pipe is going through this, again water is falling back, water or oil or bentonite, whatever we take, bentonite slurry, not bentonite, bentonite slurry. And whenever you are going for an experiment, it should have a certain purpose. Our purpose was to redesign the whole impeller system. What will be the best impeller or best design for certain fluid application? Let's say if you have high viscosity, you have slurry, so what will be the best impeller? What will be the best design for this one? So when you are doing experiment, so you need some data. You need to compare whether the original impeller was this one and you modified to this one. Okay. So when you are comparing, so you need how much flow rate you are getting, how much head or pressure you are developing. Okay. So for flow rate, we had flow meter. Okay. Then we had pressure gauge, flow control valve was there. You see this flow control valve, and motor must be there, and motor was controlled using VFD, or variable frequency drive, variable frequency drive, or VSD you can say, variable speed drive. Okay. So variable frequency drive we use because we wanted to check with different RPM also. If I change frequency of electricity, then my motor speed will change. Motor speed change means pump impeller rotation will be changing. So impeller rotation is directly linked with my flow rate. Okay. If I change speed, my flow rate will change. So that's why we purchase VFD. So here you can see one VFD we had. You see left side picture. Variable frequency drive we had. So that was supplying electricity to motor. Motor was connected to my pumping system using shaft. Okay. So shaft was delivering power or torque. Okay, shaft, what is the purpose of shaft? Shaft will be transferring torque actually, basically torque. Okay. Then we had one speed sensor, how much speed you are getting, because sometimes motor will have certain speed, let's say for 1500 RPM, but because of load, pump may not rotate at the same RPM, because if you are overloading pump, so motor speed will be lower actually. Okay, motor will try to catch 1500, but actual speed will be little lower. Okay. So there will be some slippage in motor. So pump motor slippage or slip, what is called slip. Okay. Then you got torque, pump impeller rotating, shaft is connected here, motor to shaft rotating. When it is giving delivery fluid, so you must check how much pressure you are developing. So pressure gauge must be there. Okay. So flow meter must be there. Okay. So this was the whole experimental setup. Then from that, why we calculated, what did you find?